mostly because also from grade 8, we're now starting to essentially train you to be able to write matric exams at the end of the year, at the end of grade 12. Regardless of whether you choose to carry on with maths, you're still going to write a matric exam for maths, maths lit, history, life sciences, whatever subjects you're going to do, you're going to have to write an exam. And all of these things that I have here don't only apply to maths. They apply to every subject that you have to write an exam for. Okay, so when you are starting to study for exams, some schools give, some schools don't. But the best way to study, and particularly like maths and science and stuff, really any subject, but particularly maths, is to use past papers. So the questions that I've given you today, that is one resource that you should be using as a past paper resource to study for your exams, right? If you just Google past papers, you will find many sites that give you access to past papers. Most government education websites have past papers uploaded on them. So there are lots of places where you can find past papers. And like I say, if you just Google it, you will find so many. So past papers is your first point of study. What's really important in grade 8 is studying maths does not mean reading your notes or reading your textbook. That's part of it, a very small part of it, but actually doing the questions and seeing where you're going wrong, that is how we study for maths. Right, another really important thing as you guys start to head into this exam period and you start with your study timetables and actually studying, is that you need to remember you get a set time to write your exam. Now, most grade 8 exams are between an hour and a half sort of time. When you're doing your past papers, the past paper will say, I don't know, 100 marks, 90 minutes. When you do that past paper, you actually need to, or you should, be timing yourself. Okay, so if the paper says you've got 90 minutes to do the paper, set a timer on your phone, on your laptop, on your microwave, whatever, and you time yourself for 90 minutes. That way you can see how much you have managed to do in the time period if you were actually sitting down for the exam. And you can also then see how much of the paper you still need to study for. So if you've really struggled, let's say with the equation section, you know that you've spent too much time on that and you need to go back and revise it. And this is leading us into our next point, which is time management, both in your studying, but particularly when you're writing your exam, you need to manage your time really well. And a good sort of rule of thumb when you are starting to write is a mark a minute. So if a question is only out of 2 marks, you shouldn't spend more than 2 minutes on that question. It is not meant to be a hard or a complex question. It's supposed to be relatively easy to complete. If you get a 4 or 5 mark question, then it is going to take a bit more time. And so this is why when you get reading time in your exams, it's so important that you read through your whole paper, you take note of the mark allocations, so that you can say, okay, cool, question 1 is worth 10 marks. I need to spend my first 10 minutes on it, and then I need to move on. Right, a mark a minute should then get you through the whole paper with some time to spare, probably about 10, 15 minutes to spare. And that time that you have to spare, you're going back and you're checking your work, you're checking for mistakes, you're going back to any questions you didn't answer, and you're making sure that you're happy with everything you've written down. So in terms of actually writing your exam, a mark a minute is a really good strategy to have when you're writing so that you manage your time efficiently and so that you actually get everything done. I don't know how many of you, English papers often do this. English papers will often say question 1, you should spend about 30 minutes on, or question 2, you should spend about 20 minutes on. And that's based on how much work you need to put into those questions. So starting to be aware of that stuff is really, really important. Right, this is something I tell my kids. Whether or not they listen to me is another story, but this is something I tell my children. Start each question on a new page. It might seem like a waste of paper, but there's a reason for this. The reason for this is you can then do the questions in any order. So if once you've done your reading time and you've read your whole paper and you decide, actually, question 3 is where I know I'm confident. And I know that if I start with question 3, I'm going to feel really good heading into this exam. Start with question 3. At the end of your exam, you just put all of your papers in the correct order that they should be in, and you can hand in. But if you're starting a question on a new page each time, and when I say a question, I mean question 1, not like 1.1 on a new page, 1.2 on a new page, the whole question. It just means that you can start where you're most comfortable. You can leave the stuff that you're not super comfortable with for the end. And then all you do is you put everything in order at the end, and you've at least made sure that your time has been spent wisely and you've managed your time correctly. Right. Some people like to do this, some people don't. I know I've told my kids this at times and they're like, no, ma'am, I just can't do it out of order. Whatever. It's a piece of advice. Use it, don't use it. But it's something I really strongly suggest if you know that maybe sometimes you feel more comfortable with a question towards the end of your paper. Start there. It makes sense to start where you're most comfortable. Right, guys, a silly little thing, but something that often we do wrong is make sure you indicate your answers clearly. So if your page is a bit messy with the working out and it's all everywhere, that's okay. Your teachers will mark it. It's not like we won't mark it. Make sure you've written neatly and just make sure that your answer is then clear on that page. So whether that means you highlight it or you underline it, whatever the case is, make it very clear so that your teacher doesn't have to question where your answer is. If we can see where your answer is, at least you can get those marks. So in your working out, just try and be as clear as possible and always indicate your answer. I always underline my answers. Those of you that are in my lessons on Wednesdays and Mondays, you see how I always underline my answer. And that's just to show that if someone was marking my work, they know exactly what my final answer is. Right, guys, in terms of like letting your teachers have an easy time of marking, and I know it sounds silly because like it's a teacher's job to mark, but I promise you, like when your teacher gets frustrated, it just makes the experience horrible. Leave a line between questions. Again, it's just if your working out is a bit all over the place, we can clearly see what's going on. There's also then no need for you to lose marks unnecessarily because it's very clear where a question ends and where the next question starts. Right, I've already mentioned this to you, but if you are going to leave out questions, very importantly, mark them on your question paper so that when you are going back and you're checking your work, you can see, oh, I've circled that question. I need to go back to that question and make sure I do it. Remember as well to leave enough space to actually answer them. And if for whatever reason you answer a question out of order, so let's say, for example, you forgot about question 2.3 and you went 2.2, 2.4, it doesn't matter that you answer question 2.3 at the end, but mark it very clearly. So highlight it, put a little star there, circle it, do something to make sure that your teacher can see that you have answered it out of order. Can't tell you how many times my kids will answer things out of order, but don't say anything. I don't mark them on that question. And it's only when I get to the end of the paper, I see, oh, they've actually done this question. And then I have to like readjust their marks. Obviously, we'll do that. But if you tell me right from the start, I need to be looking for this question's answer somewhere else, it makes life a lot easier. And again, you're not losing any marks unnecessarily. Right, guys, then we're a bit more lenient in grade 8, but just a heads up, you are not allowed to use any Tipp-Ex or any correction fluid. Okay, this is a matric exam rule. Cross it out neatly, get your ruler, cross it out, move on and carry on with your working out. You are not actually allowed to use Tipp-Ex or correction fluid. There are many reasons for this, but at the end of the day in matric, you are not going to be allowed to use it. And so just get used to it now. Cross out whatever you've done wrong, move on to the next line, carry on your working out. And as I've already said, make sure you write your exam neatly so that it's not, or so that your teacher or your marker doesn't miss out any marks. If we can't read what you've written, obviously then we can't mark it. So always try to be as neat as possible, as clear as possible when you're writing your exams. All right, so those are just my tips and tricks. These are the ones I would tell my kids in my own classes. For some they'll work, for some they won't. You need to figure out what works best for you. But sort of these first 4, I strongly recommend you put into practice. Past papers, time yourself, read your questions carefully. And for me, starting a question on a new page, it just makes life so much easier and you can start where you're comfortable with in an exam. Alrighty, grade 8. So I just want to check, is there any questions before we carry on and move into the actual past paper questions that I've given you for sort of the algebra part of maths. If not, we're going to head into our maths, and I'm just going to explain a couple of things before we start, but we're going to get into our past paper questions. And guys, remember, if you do have questions whilst I'm talking, put them on the chat. I see them pop up. I'll answer them as soon as I'm done. I'm also just going to wait in case anyone wants to screenshot this. Okay. Alrighty, grade 8. So let's get into it. First thing I just want to mention is in the past papers that I sent you, I very clearly stated for you that in this bootcamp session, I will be doing the ones circled. So I'm not going through the entire past paper that I sent you. We just don't have time for that. What I am doing is I'm going through the questions that I've circled, because these are the ones that A, you need to know, B, the ones we struggle with the most, and C, are the ones that are going to sort of start applying as you move into grade 9, grade 10, grade 11, and grade 12. You're going to see a lot of, no, not a lot. Some of the stuff you do in like junior grades sort of falls away when you get to grade 10, grade 11, and grade 12. But these are the really important foundation concepts that we need as we go up. I'm not saying the rest of the paper is not important. It is. You still need to go through it. But these are the ones that if we have a good foundation, we're going to be sorted for maths. All right, on that, purple block, no, bubble, whatever that thing is, please remember that you have all of the questions and you are going to get a memo. So the questions that we don't do today, or the questions that we don't get to today, you will have a memo to work through. I have done a full worked out memo. It's not just like an answer. It is step-by-step working out with mark allocations, where you're getting the marks. So you can very clearly see how you should do a question and where your marks will be. But just remember that should we not get through everything, should you want more practice, I haven't done the whole past paper and it is there for you to use. Okay. So guys, I'm going to start with question 3 under your working for numbers heading. It's the first section in your past papers. And what we're going to focus on to start off with is just working with different types of numbers, fractions, converting between fractions, operations with numbers, and hopefully being comfortable with how to do these things. Alrighty, so just a reminder, any questions, or if we're confused at any point, we put our questions in the chat. I will give time for questions, but that's where your questions go to start off with, and I will help you as we go along. All right, guys, so our first question that we have here is 3.3 that we're going to look at, and it says 3 2/3 minus 7/12. Okay, now that's a lot of information. What we need to remember is sort of our steps that go back to how we deal with fractions. So whenever we have a fraction sum, the first thing that we want to do is we want to convert all of our fractions to improper fractions. Now, obviously, if you have a proper fraction or a fraction where the numerator is smaller than the denominator, that's fine. We've got no issue with that. But if it can be converted, i.e. like the mixed number of 3 2/3, we're going to convert it so that we can then work with our fractions. So convert to improper fractions. So this therefore means that we need to take this 3 2/3 and we need to convert it. Now there's a little trick for us to convert any mixed number that we're working with. I'm just going to write it a bit bigger so that we can write this. So the trick to convert a mixed number is to take the denominator and times it by the whole number. So we would say 3 times 3, which gives us 9. And taking that answer and adding the numerator. So 9 plus 2. That gives us 11. And what this value is our new numerator to the improper fraction. Okay, so times the bottom, add the top. That's our trick to convert. Numerator. Wasn't sure if I could spell there. And so what we now have is a an improper fraction of 11 over 3. The denominator stays the same. So because we had a denominator of 3 here, my denominator of my improper fraction is still 3. That doesn't change. It's just the numerator, because we have to account for the 3 wholes that we have. We've got 3 wholes and then 2/3 of the 4th whole. That is then having the 7/12 subtracted from it. So our first step, like I say, is convert your improper fraction. Our second step is then going to be to find an LCD. Now remember, an LCD is your lowest common denominator, and essentially we want to make the denominators the same. So I go to look at my denominators. I've got a denominator of 3 and a denominator of 12. So quickly on the chat for me, what is my LCD for these two fractions? What LCD am I working with? Nice, guys. Well done. Okay, so your LCD is going to be the smallest number that both denominators can divide into. Okay, so 12 can divide into 12, and obviously 3 can divide into 12. That's the smallest number they can both divide into. Now, this LCD is already 12, so I'm happy with that fraction. I'm not so happy with the first one. So I need to ask myself, what would I multiply my denominator by in order to make it 12? Well, 3 times 4 is 12, but remember, what you do to your denominator, you must do to your numerator. This is because we need to keep these fractions equivalent. Okay, it still needs to mean the same thing. So remember, what you times your denominator by, you're going to times your numerator by, and that's going to allow you to convert your denominator. So we now have 44 over 12 minus 7 over 12. And because we have this LCD, essentially we can now combine this into one fraction. And because we have this one fraction now, our third step is going to now be to simplify my numerator. Now, when we say simplify, all I mean is you need to add or subtract the numbers in your numerator. So our numerator here is 44 minus 7. That's easy enough to do. Obviously, guys, I have no problem with you using a calculator. If you can't, this isn't too hard a subtraction. 44 minus 7 gives us 37. Panic. Right, Hayden's on it. 37 over 12. Now, grade 8s, we always want to double check if we can actually simplify our fractions. Remember, your answer should always be simplified. Now, even if you can't use a calculator and you're working out, I would just use it to double check whether or not this can be simplified. I don't know where all my calculators are. Right, so to check if a fraction can be simplified, you literally type it into your calculator, 37 divided by 12. Whatever answer your calculator gives you will automatically be the simplified answer, right? 37 over 12. That's exactly what I've written down. That means this fraction can't be simplified any further. That is my final answer. Now, grade 8s, if you want to convert it to a mixed number, there is absolutely nothing wrong with that. So if you want to write this as 3 and 1/12, that is also absolutely fine. I personally just don't like mixed numbers, so I would never convert it. However, there is nothing wrong with you converting it. And if you do, we will still give you the marks. Right? I always just leave my answer as a fraction, but there's nothing wrong with a mixed number. Alrighty, so fractions, we need to remember that when we add or subtract fractions, we need to find an LCD. Let me just add that into our little note here. So LCD is only when we add or subtract fractions, not when we multiply or divide. We're going to deal with one of those just now. Do your conversions if necessary. And then remember, once you have your LCD, you just add or subtract your numerator and you get your answer. Right. So how do we simplify without the use of a calculator? Okay, so the way you would simplify without a calculator is you would need to ask yourself, is there any number that divides into both of these? So I'm just going to change this answer quickly just so that we could potentially simplify it. Let's say I got an answer of 38 over 12. Okay, so my first question to myself is there any number I can divide into both of these? Now, most of us will initially say 2. So if we divide both of these numbers by 2, so top and bottom divided by 2, we end up with 18. We don't end up with 18. 19, yeah, over 6. And then I ask myself again, is there anything that I can still divide into these two numbers? No, because 19 is a prime number. And so I've simplified it fully. So you just need to keep dividing numbers into both numerator and denominator until you can't anymore. That's how you will essentially simplify. Okay, Sean, is it possible to put a decimal? Again, absolutely. The only time where we are strict about the answer is if we say, leave your answer as a mixed fraction, or as a mixed fraction, a mixed number. Leave your answer as a decimal. If you then don't follow that instruction, you'll lose a mark. Here, I haven't told you what to leave your answer as. Leave it as whatever. So if you put it as a decimal, that's fine. This decimal is 3,08, 3 recurring, whatever. Again, decimals I don't like, so I would never do it. But if you did, absolutely fine. Okay, so guys, Lubanzi, in terms of the mark allocation, so you are going to get marks for your conversion of the mixed number, your LCD, and then your final simplified answer. So basically, if you follow the steps that I've put there, step 1, step 2, step 3, those are your 3 marks there. All right, grade 8. So if you haven't taken a screenshot, I suggest you do so as well. Exactly as you've seen, questions on the chat, I see them immediately, I'll answer them. We'll do some questions once we've sort of dealt with all of the fraction stuff. But take your screenshots so long. Okay, so you can see that the next one that's circled is still a fraction question, but now our operation is different. The first fraction was an addition subtraction type thing. However, now we're dealing with multiplication division, and the rules or the method for dealing with fractions and division and or multiplication a little bit different. Right, so guys, if we have a look at 3.5, it's only worth 2 marks. So again, you now need to be thinking in your head, 2 marks, I should spend a maximum of 2 minutes on this and then move on with it. When we are dealing with, okay, grade 8, can I please just remind you that the questions need to pertain to the question. So it doesn't help when we're asking questions later or we're asking for screenshots later. It's just causing confusion. So quickly, how I got 44, I got 44 from my LCD step. My LCD step 11 times 44. Terrible highlighter color choice. So let's try that again. Now, LCD told me that I had to say 11 times 4, because remember, what I do in my denominator, I have to do in my numerator. 11 times 4, 44. So that's where I got the 44 from. And then I went and simplified. Okay. Guys, Kia's put there on the chat how you can screenshot on a laptop. So please take notes. Also, if you're really struggling, just grab a phone and take a photo of the screen. Okay, so you can actually screenshot on a laptop and you have now got that instruction there. But if you are still struggling, just take a photo of your phone. Okay, so back to 3.5. We've got 2/5 divided by 1/2. Now, guys, the second you see fractions and division, you automatically need to be thinking tip and times. So the first thing we're going to do is exactly that, tip and times. What this means is the division changes to a multiplication, and my second fraction flips. So this now becomes 2/1. The first fraction still stays exactly as it is. It's only the second fraction that is affected. But what we now have is 2 fractions being multiplied together. The division of 2 fractions is more complicated to deal with than multiplication. And so we have a way of converting the division to a multiplication, the times and the tip, so that we can easily go and do this, especially when we're asked to do it without a calculator. So the first thing we do is we tip and times, or times and tip, whatever you want to say. The second thing is we multiply the numerators. So me multiplying my numerators will involve 2 times 2, which gives me 4. And then the third thing that we're going to go ahead and do is we are going to then multiply the denominators. And in this case, my denominators is 5 times 1, which gives me 5. Again, always double check if you can simplify. So I'll add a little note here. Double check if we can simplify. And if you can't simplify, you're obviously then done. 4 over 5 can't be simplified because there's nothing that divides into both 4 and 5 without a remainder. Again, you could also type it on your calculator to double check that. Can't be simplified. So my final answer here is 4 over 5. So grade 8, when you are dealing with fractions and division, you need to tip in times, and then you just multiply across numerators, multiply across denominators. Right, Ashley, I don't really understand what you mean when is it fine if we do a cross multiple? I'm assuming you mean if you start from the division and you go 2 in the numerator times 2 in the denominator, which gives you that 4, and then 5 times 1. That's okay. If that's what you mean, I'm on the same page, that's fine, because that is essentially the tip and time situation. If that's not what you mean, let me know. CM Tunda, ma'am, you said why we multiply. I'm not too sure what your question is. So CM Tunda, if you just help me out there. If you're asking me why we multiply, it's because we change the division to multiplication so that we can flip the fraction and essentially just multiply across numerator and multiply across denominator. Otherwise, what you would have to do is a sort of a more complex cross multiplication step where you would have to know what's in your numerator and your denominator. Guys, again, like there's different methods to do things in maths, and I've told you this many a time. As long as mathematically it's sound, it doesn't matter if you do it slightly different to me or slightly differently to your friend. As long as the maths is correct, you will get the marks. Okay, so Lubanzi's asked if it was times, would we divide? No. So if the question had been 2 over 5 times a half, we are happy with times. So then we would just skip straight to steps 2 and 3, where we would multiply our numerators, multiply our denominators, check if we can simplify. We can, both can be divided by 2, and we would get our answer. So we only do this if it is division. If it is already multiplication, we leave it and we go straight to steps 2 and 3. Right, so we are basically, yeah, so as things start to get more complex, if you can do these 3 basic steps, obviously the more complex, it means that we're adding other rules, like maybe like exponent rules and stuff. But if you can do these 3 basic steps, you are sorted for any fraction division question. Okay, so CM Tanda, I've explained why we multiply, so hopefully that's okay. Okay, Amanda, I don't know what you mean both fractions are divided, because you can only divide one thing by another. I assume you mean if it maybe was like another thing here of like maybe divided a third, then yes, we would still have to do the same thing. So we tip in times the 1 over 2 to 2 over 1, and then again we would times and tip the 1 over 3 to 3 over 1. So yeah, every time there's a division, we just keep sort of tipping and timesing and then doing our multiplication. Okay, guys, remember, there is nothing wrong with writing your answer as a decimal. Yes, 4 over 5 is 0,8, but I've already said to you that I never write my answer as a decimal. Decimals don't really become important to us sort of from like grade 9 into grade 10. I have no problem with you writing this as a decimal. Yes, 4 over 5 is 0,8. That's fine. All right. So there's nothing wrong with that if you wrote your answer as 0,8. Absolutely fine. I don't like decimals, so I always avoid them if I can, but completely up to you. As I said, this answer is already in its simplest form, so that's why it's 4 over 5. 1 over 5, never mind, don't know why I'm getting 1 over 5 wrong. 4 over 5 is 0,8. It's the same thing. It's just one's a decimal, one's a fraction. Whichever form we're going to put down, absolutely fine. All right, so guys, let's take a screenshot here. Hopefully we're all sorted with our questions. Someone said they learned this with Teacher Coco yesterday, last year. Yes, you definitely should have. This is part of your grade 7 syllabus. I said this to some of you who were in our lessons during the week the other day. Honestly, guys, from like grade 8, we start to expect that you just know the things from primary school. In grade 9, you're going to just be expected to know the things that you learned in grade 8, and we start to build on these foundations. Okay, I hope we've all got our screenshots. Let's have a look at our next questions, which is going to involve some proportions, some percentages, some ratios, stuff that I know we don't like, but unfortunately is important. Right, before I do that, is there anyone who still has a question? Anyone who needs to raise their hand for a question? Otherwise, I'm going to move on to our next question 4. Okay, so grade 8. My answers will always be in fractions. That is just my preferred answer format. I will be better about giving you the decimal options as well, okay? Siatanda, I hope you got the answer to the why do we multiply thing. I did explain it based on your question. Okay, so Lillian, I am doing the circled questions with you. So as I said in the question paper, I will be doing the circled questions. The non-circled questions you can then use as extra practice. All right, guys, so let's have a look at question 4. Like I say, sorry about that. I don't know if you could hear the wonderful hoot outside. Like I say, we don't like proportion and ratio and percentages for whatever reason. I don't know if it's just something that we don't like the way it's taught or whatever the case is, but it's just a section that we don't particularly enjoy. But it is a section that we have to start applying more and more into more complex mathematical situations. This is also a really important part of Maths Lit. So if at the end of grade 9 or in grade 10, grade 11, you decide to make the change to Maths Lit, these concepts you have to be able to deal with. And so again, getting them right now means that later on, we're hopefully more comfortable with them. Okay, so Mr. Khadebe buys 48 jackets at 145 Rand each and sells them at 299 Rand each. Calculate the profit he made from selling the 48 jackets. Okay, so another thing that we start to struggle with or start to panic about is when there's a lot of words in maths. Here we are absolutely fine with words in English, but when we bring words into maths, we start to panic a little bit. So really important is that we can pick out the bits of information that are useful to us. So we've been told that he bought 48 jackets at 145 Rand each. Okay, so every single one of those jackets cost 145 Rand. The next bit of information that we were given is what he sells them at. So he sells them at 299 Rand each. We have been asked to calculate the profit. Okay, so those are important bits of information. The first thing is, well, what does profit mean? How do we work out profit? So guys, remember, profit is found by taking our selling price minus our cost price. Okay, so the cost price, it sort of involves how much it makes your English today. The cost price involves how much it's going to cost us to make this product. So if you guys think about, I don't know how many of you still do like bake sales at school or like entrepreneurship days where you have to make something to sell. You have to consider how much it costs you to make those items so that you can sell it and not make a loss. This is what profit is. Now, there are a couple different ways that you can do this question. I'll show you 2 of them. I say a couple, there's 2 ways that you can do this question. I'll show you both. And both are absolutely fine. And this goes back to what I said earlier. Just because I do it one way and you've done it the second way makes no difference. Both are mathematically correct. All right, so guys, the first way that we could deal with this question is we could say, okay, let me first figure out how much he spent on all 48 jackets. So what was the cost price for the 48 jackets? And all we do there is, because we know how much one jacket costs, 145 Rand, we times it by 48. That's going to give us our cost price for 48 jackets. So that is 6,960 Rand. You guys are on it in the chat. Well done. So that's how much it cost him to just get these jackets. Okay, we can say our selling price. If you want to go income, so how much money he gets from selling those jackets. We know how much he sells each jacket for. That looks like a weird angle on my J, so let's try that again. 299 Rand. He's selling 48 jackets. So again, we just multiply them together and we get how much he gets from selling those jackets. 14,352 Rand. So when it gets to our profit, remember, I've written a little formula for myself up here. Now I know what to do. I'm going to take the selling price of 14,352 and I'm going to subtract how much it cost for those 48 jackets. And when I do that subtraction, I'm going to get the amount of profit I made, which was 7,392 Rand. Okay, so guys, that's one way that you can do it. You can work out for all 48 and you can get your answer. A second way that you could have dealt with this question is you could have worked out the profit from selling one jacket and then times it by the 48. So profit from one jacket, my writing today, jacket would be your 299 minus, whoopsie daisies, sorry everyone, minus the 145. So 299 minus 145 gives me 154 Rand profit for one jacket. Now I need to figure out the profit for 48 jackets. And because I know the profit of one, I'm just going to times that by 48. Sure. You get exactly the same answer of 7,392 Rand. So guys, whichever way you choose to do it, it makes no difference. Both of them are mathematically correct. Both of them give you the same answer, as you can see, whichever makes sense to you. So if in your head you had thought, okay, cool, the first way makes sense, that's how you do it. If the second way makes more sense, that's how you do it. It really doesn't matter. Both are correct. Alrighty, so when it comes to profit, and this is sort of coming into our finance, and we do a lot more finance as we go on, we need to just remember it's the selling price minus the cost price. Okay, so let's take a screenshot again. I didn't see any questions on the chat, but just remember to keep putting your questions there. Those of you sending through answers worked out. Well done. Very, very nice. But let's have a look at our next one. I'm hoping we've all got our screenshots. Okay. Whoops. Okay, so this is a ratio question. And again, like one that we just hate. So there's probably the way that you've always been taught to deal with ratios, which I think is probably the way that gives us some confusion. And then there's a more visual way of dealing with ratios. I prefer the visual way. It's also only something that I learned how to do like 4 years ago. And so it's still like, there's lots of different ways to do stuff, guys. And the more you learn, the more you try, hopefully you find the thing that works for you. All right, but let's read our question. 3 friends, Ayanda, Jessica, and Siam, share 1,162 Rand in the ratio 3:4:7. Now remember, the order of your numbers goes with the order of the names, right? So Ayanda is 3 parts, Jessica 4 parts, Siam 7 parts. So always remember that the order of your names or the order of the items goes with your ratio. How much will they each get? Alrighty, so guys, again, lots of different ways that you can deal with this. I'm going to show you 1 or 2. Hopefully you can find one that works for you. So we've got our ratio 3:4:7. And we know that the total amount that's being shared is the 1,162 Rand. Because this is our total amount that we need to share out between the three people, we need to figure out the total of these ratio parts. So if I say 3 plus 4 plus 7, I get a total of 14 parts. Okay, so what that means is that 14 parts represents the 1,162 Rand. Now that we know that, we can figure out what one part represents. Now, guys, if you think about this mathematically, the way I went from 14 to 1 is I divided by 14. So if I do the same thing on my other side to keep this relationship in balance and representing the same thing, pretty sure this is 83, but I'm going to double check myself. If we divide 1,162 by 14, we get 83 Rand. So Ayanda is 3 parts, Jessica 4 parts, Siham 7 parts. I know what one part is now, so all I need to do is multiply. So my first calculation for Ayanda is 83 times the 3 parts that represent her amount that she gets, which is 249 Rand. My second calculation is for Jessica, who was 4 parts. So we're going to say 83 times 4, which gives us 332. And our final calculation was for Siam, which was 83 times 7, which gives us 581 Rand. Now remember the question said, how much will they each get? There we go. Ayanda, Jessica, Siam, we've got how much they each got. Right, so guys, like I said, this is probably the way that most of you have dealt with these sorts of questions. Another way that you could have dealt with this is once you'd worked out your total parts, so once we knew that it was 14 parts in total, you could have very easily have gone and said 1,162 times by the parts for Ayanda, which is 3 out of the 14. So if you say 1,162 times 3 out of 14 parts, you get exactly the same answer, 249 Rand. If you did the same thing for Jessica, of the total 1,162 Rand, she gets 4 out of 14 parts. You will get exactly the same answer of 332 Rand. Same thing for Siam. There are lots of different ways that you can deal with a ratio. You need to figure out which way works best for you. All right, so there was a question for me to go back and screenshot. I'm going to say it again, grade 8. When I say screenshot, please screenshot. Otherwise, we're just wasting silly time. All right, so there's 2 questions. Where did I get 83 from and where did I get 14? I'm going to start with the 14. Exactly as Kia said on the chat, 3 plus 4 plus 7 gives us a total of 14 parts. This then leads us into where did I get 83? If 14 parts represents the total amount of 1,162, if I want to work out what one part represents, I would divide 14 by 1, and then I'd also need to divide the 1,162 by 14. And that's where I get 83 from. 1,162 divided by 14, so 14 parts, gives me 83 Rand. All right, now guys, remember, you don't have to do it the first way. If you want to do it as the 1,162 times 3 over 14, 4 over 14, 7 over 14, that's fine. You have to figure out which of the methods works best for you, which one makes the most sense for you, and then you can go and use that specific method. All right, so because there was a request to screenshot the question before, I'm just going to make that a touch smaller so you can screenshot both if you still need to. Let's take our screenshots. If anyone needs to raise their hand for a question, now is the time to do so. Otherwise, we've got some algebra to move on to. Guys, I told you we were going to fly. We've got 35 minutes. How crazy is that? Okay, guys, I think at this point, this might be a good time that if you need to just get up, stretch, run to the toilet, run and get a glass of water, you quickly do that. I'm going to get started again in 2 minutes. So you have got 2 minutes to do what you need to do. Take a little brain break, and then we're going to carry on with the algebra because the algebra is really important. This is the stuff that we need to know in paper 1. All right, so have a quick moment, get yourself pumped and ready, and then we're going to carry on with the algebra. Whew. While you're taking a break. Those of you that are in my lessons with me normally, you know that I have cats. They're joining us today, but being very lazy. That's him asleep in his bed right now. He's just happy as a lamb in his little bed, fast asleep, sort of keeping us company, but not really doing much. Bottle of apple juice, awesome. Apple juice, I can imagine it's keeping you going. Yeah, Zingubeni, he's very cute. Like, these cats are like my children. I would kill for them. I don't have actual children at this point in my life, but they are my actual children. 1.5 liters. Oh, you're going to have to run to the toilet as soon as this is done. I can barely get through like a baby bottle of water throughout the day. Seth, their names are, so this little orange one is called Louis. And then I've got a black cat whose name is Bagheera. So when we got them, I got one of my classes. I don't know why I made this choice, but I let one of my classes name them. And for whatever reason, they were thinking of Jungle Book. So he's King Louis, which I think is the orangutan in Jungle Book, if I remember correctly. And then Bagheera is obviously Bagheera in Jungle Book. So now I just need more cats so I can name them after more characters. My boyfriend doesn't agree, but I feel like we need the whole Jungle Book cast. CM Thunder, they would probably be shocked, if I'm being honest. Okay, guys, those are our 2 minutes. Let us get into this algebra. Right, so I hope we've all got our screenshots. I am moving away. I'm not coming back because it's been up for a while. Let's get into our algebra. Okay, so guys, with algebra, what you need to remember is you're dealing with variables. Ooh, one of those things we have to deal with in maths. We need to know what's going on. Now, those of you that were with me right from the beginning of the year will remember this discussion that we had of like terms. And when it comes to algebra, this is so important. So like terms have the same variable or variables. So what I mean by that is if a term has x in it, it will be a like term with another term with x in it. But we can also have xy and another xy term. As long as they have the same group of variables, they're like terms. And the variables must have the same exponent. So what I mean by this is x and x squared are not like terms because one x has an exponent of 1, the other x has an exponent of 2. Those are different exponents. They're not like terms. So if you're with me, what you need to remember is your highlighters or your colored pencils or whatever, and you go and highlight your like terms. So question 2.2, not too complicated because hopefully what we see here is that they are all like terms because they all have an a in them. And so once we know what our like terms are, we just add and subtract them. Now guys, think of a number line when you're doing this, especially if you're not allowed a calculator. I don't know why I always make the choice to draw the number line so late in the day, but anyways, we move. Okay, here I am at 3. 3a minus 2a, so minus 1 minus 2, I'm now sitting at 1a. That's not it though. I still need to subtract 5. Minus 1, minus 2, minus 3, minus 4, minus 5. I end up at negative 4a. So my answer here is minus 4a. Now, grade 8s, obviously, if you do not need a number line, don't draw the number line. But if you do, it is a very useful tool to be able to add and subtract in algebra, or even just normal numbers, 3 plus 2 minus 7, whatever. It is such a useful tool, especially if you can't use a calculator. So if you know you're not allowed a calculator, my advice, take a piece of paper that you get in your exam, draw a number line on it, and you just keep using it for your questions. At least you have a tool to help you do what you need to do. All right, so that's nice and straightforward. We add our like terms, nothing too tricky there. It's 1 mark. So again, 1 mark, 1 minute. It shouldn't be a hard question. If we look at our next question, it's 2 marks. So a little bit trickier, but still nothing that I should be spending more than 2 minutes on. So grade 8, just quickly in the chat, what do the dots in between these factors mean? So what does the dot mean between the x squared, the 2x cubed, and the 5x to the power 4? Good, guys, well done. So they mean multiply. So if when you see that you don't particularly like that, just write it out with multiplication. Okay, there's nothing wrong with you writing it in a format that makes more sense to you. You have to do what makes sense for you. All right, so guys, when we are multiplying, this is when we need to remember our SNV. If you weren't with me, this probably sounds a bit strange. But SNV, remember, is our way that we deal with multiplication and division in algebra. We first deal with the signs, then we deal with the numbers, then we deal with the variables. Okay, so remember SNV. I feel like I said SNV to the point where you probably all wanted me to shut up at one point this year, which is fair, but SNV. So in this case, I've got positive times positive times positive. Sign is sorted, it's only positives, so my answer is going to be positive. Then I deal with my numbers. Now, guys, importantly, these numbers that I'm talking about are the coefficients. So for your first factor, it's got a coefficient of 1. So 1 times 2 times 5. Well, 1 times 2 is 2 times 5 is 10. Then we go and deal with the variables. Now, what we need to remember with the variables are our exponent laws. Okay, now remember, when you are multiplying, we add the exponents. And because we are multiplying here, all we need to do is we need to say 2 plus 3 plus 4. My base stays x, that doesn't change. It's the exponent that changes because now we are applying our exponent law. 2 plus 3 is 5, plus 4 is 9. So my final answer here, 10x to the power 9. And I've simplified my expression. So in that, there was a lot that needed to go on. We needed to remember our exponent rules. We needed to remember SNV, excuse me. And then we just needed to remember the basics of multiplication. So this is why throughout the year, I say we, your teachers and me, we give you these tools like SNV, like the exponent laws and how to remember them, so that when you get to questions that combine them, we're able to do it comfortably. Okay, so guys, let's take screenshots of those two. If anyone has any questions, now's the time to raise your hand before we move on. I didn't see any questions in the chat, but obviously if I miss anything, you just need to let me know. That looks like we're okay so far. Okay, screenshots, I'm about to move. Alrighty. Okay, so guys, what you'll see in your exams, and I mean in your tests as well, is that the first question, so 1.1, 2.1, 3.1, whatever, the first question is generally an easy question. Second one a little bit harder, And as we move on within that question, things start to amp up a bit. And you can always expect this. This is just how it will always be from now until matric. First question, nice and easy, and starts to get more and more complex. The reason I'm saying this is as you start to get to your sort of end of questions, they are supposed to be harder. And so if you are struggling with them, again, you need to think you'll mark a minute. If you spend 5 minutes on a 3-mark question struggling with it, move on. Okay, move on from it. You can come back to it, but there is no point in sitting and struggling with something if you don't need to. Right, there are supposed to be more complex questions as you get towards the end of a question, so bear that in mind. And I always say to my kids, if maths is not your strong suit, those questions are not for you in that exam time. Absolutely, go back and do them if you have some time at the end or whatever the case is, but don't sit and struggle when you know you can be getting marks elsewhere. Grade 8, someone is not on mute. Please, let's just remember to be muted. Otherwise, it causes distraction. So let's have a look at 2.5. Now, 2.5 is a slightly more complex question because what we need to first do is we need to first identify our term. Okay, grade 8s, we are not now unmuting ourselves to cause chaos just because I've said it. We've had a lovely hour so far. Let's not ruin it. Right, so we need to identify our terms. Now remember, terms are separated. Right, the next person to unmute themselves on purpose, you're going to be removed because now you're just doing it to be a distraction and to cause disruption. Right, terms are separated by plus and minus signs. So that's what we need to look out for here. So what I would do is I would grab my highlighter and I'm going to identify those plus and minus signs for myself. Because anything now in between the signs, so everything that sits on one side of the sign, in between the signs and on the other side is a term in its entirety. So 3 times A is a term, 4 times A times B is a term, minus 2 times A is a term. And as Chantal's has put there on the chat, we now have our terms. 3A plus 4AB minus 2A. That looks a whole lot nicer. Now we can go back and we can identify our like terms for ourselves. So remember, like terms, same variables. So 3A and 2A are like terms. 4AB is a separate term because it has that B in it. So 3A minus 2A is 1A. And then we've just got our plus 4AB because it didn't have a like term to it. It stays as it is. Guys, remember, if you put the 1 in front of the A, that's absolutely fine. You don't have to. If you do, that's okay. So there's not a lot of working out for this question, but your 3 marks are coming from you being able to identify your terms, seeing your like terms, and simplifying to get your final answer. And so if you can't identify your terms, you're losing 3 marks. Now, if you think of it in terms of like a 50-mark test, 3 marks is 6%. Okay, that's a lot of marks to lose unnecessarily. Okay, so why is it 1A? Because 3A minus 2A, so if we subtract those like terms, that gives me 1A. You don't have to write 1A. If you just write A, that's absolutely fine. But it comes from the like terms that I've highlighted in pink. So, and you saw that I have put my like terms together. There they are. If you mean write them together, that's absolutely fine. So if you would prefer to first say 3A minus 2A plus 4AB, and then have your A plus 4AB, that is absolutely fine. Whoops. That's absolutely fine. You don't have to. You don't have to write them together. But if you want to, that is obviously perfect. Alrighty, guys. So let's have a look then at 2.7 here. So 2.7, we now have a bracket involved. Now, grade 8, what does the bracket imply? What operation does the bracket tell us to use? I'm actually asking you the question. So on the chat, what operation does a bracket mean? Good. Nice, guys. Okay, so at the basis of it all is we need to apply BODMAS. And BODMAS tells us that we should be multiplying before anything else. Now, I think it was Lubanzi. Let me just double check. Lubanzi identified it quite well, and Sean, in that it is multiplication through distribution. So distribution means that we know we need to multiply, but specifically, we want to take this coefficient of negative 5x and we need to multiply or distribute it to each term in my brackets. Now remember, this is where we take our multiplication block. So we've got our little multiplication block, our working out on the side for ourselves, and we can do our multiplication. So we have minus 5x times 2x, and we have minus 5x times minus 3. And again, grade 8s, whenever you're doing multiplication and division, SNV. So for the first multiplication, we have got a negative times a positive, which is a negative. So signs are sorted. Numbers, 5 times 2 is 10. Variables, x times x is x squared. For my second multiplication, a negative times a negative is now a positive. 5 times 3 is 15. And then we just have the x there. There's no other x to be multiplied with, so it just stays x. And now because we've done that distribution, we know that we are working with negative 10x squared plus 15x. Now, grade 8s, remember, these are not like terms. And they are not like terms because one term has an x squared and the other an x. Because they are not like terms, we can't add or subtract them. And so this is my final answer for 2.7. So really, really importantly, again, your SNV, your signs, numbers, variables, when you're multiplying or dividing, and always double checking whether or not you have like terms and can you add and subtract the terms that you have. So exactly as Kia said, let's take our screenshots. If anyone has any questions that they need to raise their hand for, let's do it now. Good, guys. Well done.
Let me leave a story on WhatsApp. Yeah.
Right, so guys, I'm just going to jump to 2.11 because there's still another section that I want to do before we end off. And like I said to you, it doesn't matter that we don't get through everything. We get the memo and it's all worked out, but there are a couple things I want to remind us of. So 2.11 is an exponent type question. Now we have dealt with exponents in the last couple at a very basic level, but obviously we need to apply our exponent laws properly. Now, whenever you are trying to simplify an expression, as was said earlier, BODMAS needs to come into our heads. Now, BODMAS tells us, some of you work with BODMAS, PEDMAS, BEDMAS, whatever. Your order of operations needs to be correct. So if we have a look here, we've got a bracket that says 2a cubed times 3ab squared times another bracket of negative 3a squared b, and that bracket has been raised to the power of 2. There is a lot going on here. So what I would do is, because BODMAS tells me to deal with my brackets first, that's exactly what I'm going to do. So in my first bracket, I've got a multiplication. Again, SNV, 2 times 3 is 6, a cubed times a is a to the power of 4, and then we have the b squared. So I've dealt with the first bracket. The second bracket has an exponent. Okay, so how you choose to deal with this is up to you. But what I want you to remember is that anytime you have an exponent, it is telling you how many times to multiply your base. So this is actually saying negative 3a squared b times negative 3a squared b. This squared is telling me that I'm multiplying my bracket twice. Now, because we understand, or because we now understand what that means, we can start to deal with the multiplication. A negative times a negative is a positive. So positive, 3 times 3 is 9. A squared times a squared is a to the power 4. And b times b is b squared. Now, grade 8s, if you consider this as the distributive law of exponents, that is obviously absolutely fine. But just remember that you are squaring a negative 3. Negative 3 times negative 3 is positive 9. So you always just need to remember your signs. Now that we have the bracket sorted, we can move on to the multiplication. Okay, so if you wanted to write this without the brackets, because everything inside the brackets has been simplified, and just use a multiplication sign, that's obviously absolutely fine. And now we do our multiplication, so now we have to deal with SNV again. Positive times a positive is a positive. 6 times 4 is 54. A to the power 4 times a to the power 4, we add the exponents, so a to the power 8, and b squared times b squared, b to the power 4, because again, I add the exponents. So guys, when you are dealing with exponent type questions, always just remember your order of operations, or your BODMAS, PEDMAS, BEDMAS, whatever. As long as you do your order of work correctly, and you then apply your exponent laws correctly, as we have done here, you will be absolutely fine. Sean, I'm not too sure what HEDMAS is. I don't know if you mean PEDMAS or BEDMAS. They all mean the same thing, if I'm being honest. So BODMAS, PEDMAS, a BEDMAS, all mean the same thing. Okay, so obviously the MAS, multiplication, addition, subtraction. I don't know why I didn't include division. Division, multiplication, addition, subtraction. The O and the E is order or exponent. So as long as you're dealing with the power or the exponent, you've dealt with that. BP, so B is brackets, P parentheses, but both of them basically mean any brackets that you have, you need to deal with first. Like I say, they all mean exactly the same thing. Some people just use slightly different words in order to deal with the order of work. No, Sean, don't worry. As I was saying them, I was like, they all sound very similar, so don't stress. But yeah, they all mean the same thing. As long as you can apply whatever you use at school, absolutely fine. Okay, so guys, let's take our screenshots, because I'm going to jump to the equations, because that is another really important section that we need to be able to deal with. Oh yeah, so Caleb's got BOMDAS, so multiplication, division, swap. Absolutely, because division and multiplication have the same level of importance, so do addition and subtraction. So if you did that, it's fine. Generally, we just work left to right if we have division and multiplication. But yeah, like I say, as long as it's what you've learned in school and you're not just making it up, absolutely. But BOMDAS is absolutely fine too. Okay, so guys, equations, like I said, I'm just jumping to the equations, and I'm going to start with 1.4. Because you've done equations in grade 7, we have done equations together. Those of you that have done Watobe, I want to say since the start, but I actually think we did equations in term 2, end of term 2, maybe even term 3. We have done it. So you can go watch the videos on the website, but equations is a really important part of your paper 1. It also becomes so important in pretty much every single section in maths. So it doesn't matter if you're doing geometry, you'll have an equation that you'll need to deal with. If you're doing graphs, you'll have an equation that you'll need to deal with. If you're doing statistics, you'll have an equation that you need to deal with. Equations comes up everywhere. We need to be able to do them. Okay, so guys, if we have a look at 1.4, we have got 4x minus 21 equals 5 minus 9x. Now, we have written down steps for this before, but obviously for those that potentially weren't with us for equations, I'm going to write them down again. Step 1 is we get all x terms to the left. Now, guys, I say left-hand side because for me, our answers are x equals. So the x is always on the left. It doesn't matter if you put them on the right. It makes no difference. All right. As long as all your x's are on one side and your constants on the other side, you're fine. I just say left. If we keep left in our heads, we can't go wrong. What that then means is all our constant terms must be on the right or on the other side. And when I say get, I mean we need to use our inverse operations or opposite operations. So it's not just you moving things as you please, it's actually using inverse operations. Once you've done those two things, you can obviously solve for your unknown. So let's have a look at our question. We can see that we've got a 9x currently sitting on the right, a negative 9x rather, currently sitting on the right-hand side. We wanted to join the 4x on the left. Now, inverse operations would mean that I should add 9x on both sides of my equation. That will get rid of it on the right, but reintroduce it on the left with the opposite sign. So 4x minus, 4x plus 9x minus 21 is equal to 5. The negative 9x through inverse operations is now grouped with the x terms on the left. But that also means that now I need to get this negative 21 to join the constants on the right. Again, using inverse operations, I would have to add 21 on both sides of my equation. So now I'm left with 4x plus 9x on the left and 5 plus 21 on the right. Inverse operations. Because I've now got essentially like terms on either side, I can add them. So 4x plus 9x is 13x. And 5 plus 21 is 26. Again, when I'm solving my equation, I'm doing all of this through my inverse operations. And often what happens is now I will have a coefficient or potentially even a fraction that I now need to deal with. Now, guys, this is 13 times x. So the opposite or the inverse operation here would be to divide by 13. But remember, what you do on one side of your equation, you have to do on the other side. So I also need to divide 26 by 13. Now, 13x divided by 13 leaves us with just x, but 26 divided by 13 is 2. And so I'm able to solve for x. Now, guys, remember, you can double check yourselves. If you go and substitute your answer back into the original equation, you should get that the left-hand side is equal to the right-hand side. So if we just do that verbally, 4 times 2 is 8, and 8 minus 21 is negative 13. So my left-hand side is negative 13. I then have 5 minus 9 times 2. Now negative 9 times 2 is negative 18, and 5 minus 18 is negative 13. So again, on the left, I've got negative 13. On the right, I've got negative 13. Because they're equal, my equation has been solved correctly. So always remember that you can check your solutions to your equations through substitution. Right, any questions? Do we need to raise our hands for any questions? Otherwise, take your screenshots and we'll have a look at hopefully 2 more, but maybe 1 more. Okay, so Abongilez asked in the chat, would it be wrong if I put 4 to the other side? Absolutely not. If you want to put the 4x to join the negative 9x and have minus 9x minus 4x, that's fine. As long as you remember your inverse operations, like I said earlier, it doesn't actually matter which side you put them on, as long as your inverse operations are correct. And so you saw all of my signs have changed, so I'm not too sure where you're looking. If you're talking about the division, we don't change the signs with division. We only change the signs when we're doing these inverse operations, when we're moving the terms over the equal sign. That's the only time my signs are going to change. Otherwise, the inverse of multiplication, like I said, is division. So we're doing the opposite. See, so?
I mean, right by the equation, there's a plus and a minus. Doesn't the minus go to the left hand side, and the plus comes to the right hand side?
Okay, so just when you say the equation, can you just tell me specifically which plus and which minus?
In the first equation that you gave us.
This one or like the written down one?
The written down one.
Okay, so which terms are you talking about? Sorry, I'm just not seeing the plus and minus that you're talking about. So which terms specifically are you talking about here?
Oh, ma'am, like, right, our teacher told us if there's a plus and a minus, the minus comes to the left hand side, and the plus goes to the left hand side. So I'm a bit confused with that.
Okay, so what would you have done? What would you have put where?
I have put the minus sign by the left hand side, and the plus sign by the
okay
right hand side.
I want you to tell me with the numbers. So tell me 4x plus whatever or 4x minus whatever, just so I can understand what you're doing in this question.
Okay, ma'am. So I said 4x plus 9 equals 5 minus 21.
Okay, so I agree with your plus 9. Do you see that's exactly what I did on the left-hand side? So I absolutely agree with that. However, if you're going to bring the 21, so what you're doing is you're taking this negative 21 and you're bringing it to join the 5 on the right-hand side. It has to change its sign. So it has to become plus 21. It's no longer minus 21 if you're changing the side of the equation that it's on.
Yes, ma'am.
Okay, good. Right, so guys, the inverse operation stuff is really important. If you don't change the sign, then you haven't taken into account the balancing of your equation. I'm not too sure why I can't mute you now in CSO, but I can't really hear you. I can just see you're not on mute, but it's fine. All right, guys, let us do one more equation.
I just get
and I'm going to skip to 1.8 just because it's got a fraction in it. For whatever reason, we sometimes panic with fractions, but there's no need to. Right, so guys, your basic rules don't change. Get your x terms on one side, constants on the other, and you're sorted. Now, in this question, I actually only have one x term. It's just x over 2. So what I actually, all I actually need to do is deal with this negative 3. I need to bring it to join the plus 7. So inverse operations tells me I'm going to add 3 on both sides. So that leaves me with x over 2 is equal to 7 plus 3. Now we know that 7 plus 3 is 10. And so I've got x over 2 equals 10. Now guys, again, inverse operations. All we need to remember is that the inverse of division is then multiplication. So what I want to do is I want to take this fraction and now times it by 2. And remember, that's technically 2 over 1. Because what happens is my 2's essentially cancel each other out and I get rid of my fraction. So now all I'm left with on the left-hand side is x. But remember, you can't only do something to one side of your equation. If I'm going to times the x over 2 by 2, I need to times the 10 by 2 as well. And we know that 10 times 2 is 20. So the only thing you need to sort of have added to a question where there's a fraction is the fact that the inverse or the opposite operation of a fraction is to multiply. We saw, I'll come back to this in a second, we saw here that the inverse operation when we had a coefficient, so the 13x, because it was 13 times x, we divided. But if we have a fraction, the inverse is to multiply. So you always need to think back to what is my inverse operation and how do I essentially solve using my inverse operations. All right, grade 8. So anyone with any questions? We've got 1 minute. So I told you this hour and a half would fly. If you've got any questions, raise your hands. What I will do my best to do is next weekend, should anyone have any questions about paper 1, I'll try and make some time at some point in there, 5-10 minutes, to deal with any last minute questions from paper 1. But again, you are getting the memo, you have all of the questions, they are there for you to have a look at. All right. Seth asked for another example of 1.8, so let's go. Okay, so Seth, have a look at that. What I'll do, Seth, for you, and anyone else who's going to try this one, is on the welcome screen of next weekend's bootcamp, I will put the answer to this question, so you can mark it if you're going to give it a try. Otherwise, again, guys, you've got all of the questions. You'll be getting the memo. You're going to get the recording or the link to this recording, and you have all of the videos on Watobe's website.